When the Great Depression stripped households of steady income, fuel became as precious as food. Coal, firewood and electricity were rationed by circumstance, not policy. Families learned quickly that staying warm was not about burning more fuel, but about refusing to waste the heat they already paid for. Out of this necessity came a quiet innovation practiced in farmhouses, tenements and workshops across North America and Europe: heat recycling. It was not a device sold in catalogues or a patented invention. It was a method of capturing, storing and redirecting heat that would otherwise vanish up chimneys or leak into the night. This trick kept homes livable through winters that broke spirits and bank accounts alike, and honestly, it remains just as effective today. Why Depression-era families could not afford to let heat escape. In the 1930s, heating a home was a daily calculation. Coal scuttles emptied quickly, firewood piles shrank visibly, and stoves went cold if fuel ran out. Central heating was rare, and insulation was minimal by modern standards. Families understood that every degree of warmth lost meant more labour, more cost, or more suffering. They began paying attention to where heat went after it was produced. The answer was uncomfortable. Most of it escaped unused. So, here's how the stove ended up at the very heart of heat recovery, you see. Wood and coal stoves, well, they were quite efficient at producing heat, but honestly not so great at actually keeping that warmth inside the home. Hot gases would just rush straight up the flue, taking all that precious heat with them. During the Depression era, households found ways to counter this problem by basically slowing down the escape of heat. They would extend the stovepipes horizontally before they reached the chimney, often running them through extra rooms along the way. The longer the pipe, the more heat would radiate into the house before the smoke finally exited. And this was not just some kind of guesswork. People could feel the difference right away. Now, the thing is, stovepipe routing actually mattered more than the size of the stove itself. A large stove, well, it just burned fuel faster, but a smart pipe layout that burned fuel for a longer period. By increasing the surface area inside the living space, families could turn exhaust heat into usable warmth. Pipes were kept clean and carefully angled, to maintain the draft while getting the most heat transfer possible. This clever approach allowed smaller fires to heat larger spaces, and it really did reduce fuel consumption quite a bit over the course of a long winter. Now, you see, thermal mass was used to store heat long after the fire had died down. Heat recycling, well, it didn't stop with pipes. Families would place bricks, stones, or even cast-iron objects near their stoves to soak up warmth while the fire burned. And then, once the fire burned down, these materials would slowly release that stored heat for hours, keeping the chill at bay. This clever approach helps stabilize indoor temperatures right through the night, and all without burning any extra fuel. In some homes, folks even thickened the walls near their stoves or lined them with masonry, all for this very reason. In a way, the house itself became a kind of heat battery, storing warmth for when it was needed most. So, why did water play such a role in Depression-era heat retention? Well, water holds heat exceptionally well. That's the thing. People kept pots, kettles or tanks of water near their stoves, not just for cooking, but to store heat. As the water warmed up, it absorbed excess heat that would otherwise just disappear. Then, overnight, it would gradually release that stored warmth. Some households even put water-filled containers under beds or along the walls to cut down on nighttime chills. This wasn't about luxury, not at all. It was simply physics, applied out of sheer necessity. You know, back then, heat was redirected rather than generated anew. Curtains were hung strategically to trap warm air in occupied rooms. Doorways were sealed with rolled fabric, and floors were layered with rugs and even newspapers. Warm air was guided where people lived, not wasted heating unused spaces. The goal was always the same, really: keep existing heat working longer. Why did this method succeed without modern materials? Well, there was no fiberglass insulation, no foam sealants, and certainly no powered fans. Everything relied on observation and restraint. Heat rises, hot surfaces radiate, air leaks steal warmth. By reducing escape routes and increasing absorption, families achieved results that modern homes often fail to match, even with all our advanced technology. So, how can this trick be applied safely today? The principle still works. Modern wood stoves can benefit from longer internal stovepipe runs where code allows. Thermal mass, like masonry or water containers, can be placed near heat sources to store warmth. Sealing drafts and controlling airflow remains essential. But the key is safety. Chimneys must be clean, clear and compliant. Carbon monoxide detection is mandatory. Depression-era families accepted risks, modern households simply should not. The method survives, but it must be adapted responsibly. Why does this approach matter in today's world of energy uncertainty? Well, fuel prices, they fluctuate. Power grids, they fail. Emergency heating, it becomes a concern again and again. The Depression-era heat recycling trick, you see, it reduces dependence on constant fuel input. It stretches what you already have. In prolonged outages or off-grid situations, this kind of efficiency can honestly be the difference between endurance and exhaustion. So, what does all this teach us about true backyard wisdom? Backyard wisdom, it's not about gadgets, it's about understanding systems. Heat, well, it's expensive to create and so easy to lose. The families of the 1930s, they learned to respect that imbalance. They didn't invent new energy, but they sure refused to waste it. That mindset, it's truly timeless. Now, why does this lesson deserve to be remembered and reused? The Great Depression, it forced ordinary people to become engineers of their own survival. Their solutions were practical, repeatable, and honestly rooted in natural law. Heat recycling wasn't a trick in the sense of deception, it was a correction. It fixed a problem everyone had just accepted as inevitable. If you value practical history that still earns its place in modern life, do consider subscribing to Backyard Wisdom and share this episode with others who believe the past still holds working solutions. Efficiency, it's not new, it's simply remembered.